So good morning to all. So this is Kumar from SNS College of Technology and the Department of Computer Science Engineering. So now I'm going to tell about swapping and contiguous memory allocation and memory management. So first thing is swapping. So a process can be swapped temporarily out of memory. So and it to be a backing store. So and then brought back into memory for a continuous execution. So total physical memory space of a process can exceed a physical memory. So in swapping we have two concepts. One is a backing store and rollout and roll in. So backing store means a fast disk large enough to accommodate and copies of all memory and images for all users, and it is provided to direct access and these are memory usages. So roll in roll out means a swapping variant used to priority based scheduling algorithms, and the lower priority of process swapped out to higher priority. So the process can be loaded and executed. So major part of a swap time is transfer time. So total transfer time is directly proportional to the amount of memory swapped. So the system maintains a ready queue of a ready to run a process, which we have to memory images of on disk. So does the swapped out process need to swap back into the same physical address? So it is depends on addressing binding method. So and the plus consider of depending on the input output of the process from the memory space. And also it is modified versions of a swapping are found on many systems, for example Unix and Linux and Windows. So swapping normally disabled and started life more than a threshold amount of memories allocated. So initial swapping, so disabled again once memory reduce below threshold. Semantic view of swapping. So we have a main memory and a backing store. So in the main memory we have an operating system with the user space, and we have to one process P1 process swap out into the backing store, and one process is swap into the main memory from the backing store. So if a next process to be put on a CPU is not in memory, so need to swap out process and a swap in target process. So it contains context switch time can then be a very high. So we have a under MP process swapping to hard disk with a transfer rate of 50 MPs per second. So swap out time is for 2000 ms and the plus swap in of same size is possible. So total context switch is swapping compound time of 4000 milliseconds or 4 seconds. So it can reduce if reduced size of memory swapped by knowing how much memory really being used. The system calls to inform OS of a memory use by a request memory system call and release memory. So other constraint as well on swapping. So pending input output, it cannot swap out as input out would occur to wrong process, or always transfer input output to kernel space then into input output device. So it is known as a double swapping and overkill. So standard swapping is not used in a modern operating system, but modified versions common. So swap only so when free memory extremely low. So swapping on mobile systems, so not typically supported flash memory based. So it is in a flash memory based, and it is also small amount of space used in a mobile phone, but in a limited number of writing skills and reading skills are available. So there is a poor throughput between flash memory and CPU on mobile platforms. So instead so use other methods to free memory. So if a low, then if input output as this apps to voluntarily, so and relinquish allocated memory. So read only data thrown so out and reload from a flash if needed. Failure to free can result in a termination. So Android terminates apps if a low free memory, but first writes application state to flash for a fast restart. So both OSs are supporting paging and discussing below. So contiguous memory allocation. So in it means it is a main memory must support both OS and user process, and also it is a limited resource can be used and must allocated efficiently. So in a contiguous memory allocation, it is a one yearly method, but in a main memory, so main memory usually into two partitions. So resident operating systems and usually held in a low memory, so with interrupt vector. So user process then held in a high memory. So each process contained a single contiguous section of a memory. So in a relocation register used to product use the process from each other and from changing operating system code and data. So the can then allow the accession such as a kernel code being translation and the kernel changing sizes. So the limit registers contains range of logical addresses, and each logical address must be less than the limit base address. So So this is the hardware support for relocation and limit registers. So you have a CPU and memory. So in between CPU and memory, we have a logical address and a physical address. We have to address the limit and base addresses. So the address is less than means it is added to physical address and then into memory. It is a no means it is addressing, is create the addressing errors. Multiple partition allocation. So in a multiple partition allocation, the degree of multiprogramming is limited by number of partitions. So it is a variable partition is size of efficiency. So it is whole the block of available memory and the holes of various size are scattered throughout the memory. So when a process arrives, it is allocated memory from a hole large enough to accommodate it. So process exiting free, it's a partition. So adjacent free partitions combined operating system and maintained information about allocation partitions and pre partitions. So in a dynamic storage allocation problem, we have a first bit, best bit and a worst bit. So allocate the first bit whole to the big enough, and then best bit allocate the smallest whole that is big enough. So must search entire its unless ordered by size, and it is a produce the smallest leftover whole. So when it is considered the worst bit, so allocate the largest whole must also search entire list. And fragmentation. So we have two types of internal fragmentation. One is external fragmentation, internal fragmentation. So the total memory space exists to satisfy requests, but it is not the contiguous. This is called the external fragmentation. So we have a allocate memory may be slightly larger than the request memory. So this side difference is memory internal to partition, so but not being used. This is internal fragmentation. So this is all about our swapping concept and contiguous memory allocation and memory management. So we will see in the next thing, remaining things we will see in next lecture videos. Thank you.